Actually, it's not the first time in front of you, and it's always a pleasure. The 350 is in the end of its development. Very soon it will reach its customer. And just a year ago, when we were here together, most of you were here, I guess, we were just preparing the first flight. So what I want to show you today is what are the topics that keep me awake by days and sometimes by night as well. So these topics are in fact four. From the very top level view, we have of course the first deliveries. It's very important that we succeed our path to the launch customer, Qatar Airways, and we are working a lot on this, and there is still a lot to do before we can get there, but we have a good story here. But of course, reaching the customer means a lot of responsibilities for us. So he's going to operate the aircraft day and night with passengers, so maturity for the customer is one big topic for me now, making sure that customer can operate this aircraft. But maturity is also equally important for our industrial system, for ourselves, for our suppliers, because this is an aircraft that we want to produce very quickly at a high rate, because the market is expecting it, and that's the second good reason to have a mature aircraft and mature design. So I want to address these topics and of course how this all flows into the Dash 1000 variant that is now well into its development path and making actually very impressive progress. So just 1 year ago we were preparing the first flight, 14th of June, and this is what happened since then. 4 aircraft are flying almost daily, and sometimes several times a day. If you work out the number of flight hours, it's more than 1900 hours. So we are well on track to execute the flight test program that will enable us to certify the aircraft. I know you will have a more detailed briefing tomorrow on the flight test, and therefore I won't expand too much on this. From a program point of view, the next important milestone is the delivery to the flight test team of MSN5, which is the aircraft that is very close to the aircraft that we will deliver to the customer, with the exception of its cabin, of course. Otherwise, this is the one that will demonstrate reliability and that will achieve the last step towards the certification. And for that we have a lot to do, and in particular we will have the route proving campaign, which will clear the way to the ETOPS certification at EIS. So that's very important event that and hopefully before the end of the month we will have this MSN5 flying. But equally important are the first 2 customer aircraft. These 2 customer aircraft are following a parallel path in the final assembly line. They are today they are at a very high level of completion already, and then when we want to start installing the cabin, it will mean that we are confident that we can install the cabin and then start the delivery process with our customers, and we know that here we will have a very interesting journey. So that's the two sides of our development. How we got there. I think what was a very good achievement, and I just remind you this one, because last year I was speaking on how we had prepared the static test campaign with our static test aircraft And last year we were demonstrating. We were at the end of the demonstration of what was necessary for the first flight. We set to ourselves the target of demonstrating 1.25 limit loads at the time. And then we continued on a very successful trend until the end of last year, when we finally passed the ultimate load test with ES. And you can see here the impressive results and deflection that we had on the wing. So that was a very important achievement, because for sure this did a lot to achieve the maturity of the design from a structural point of view. There is another very important stream of actions to certify finally and to qualify the structure for operations. That's the fatigue test campaign. We are well into this fatigue test campaign already. We have four specimens participating to it. In fact, we have cut the aircraft in three parts: the front, the aft, and the center of fuselage, including the wings, plus an additional wing, which is on its own, but which is there to recognize that this aircraft is made of composite. The wing has composite and metallic parts, and the two parts need to be exposed to different testing cycles. And this is why we had cut this campaign for the center of fuselage in two. One was to qualify the wing first under a composite fatigue spectrum just for the composite itself. And then when it was done to a certain extent, and we had demonstrated that we could go to one design service goal and then pass the ultimate load, the testing of the wing itself, then we could start the campaign of what we call EF2, which is center of fuselage plus wing, and this time with a different type of fatigue cycles, which will clear the way towards several design service goals. So now, in terms of achieving the minimum required for certification, we have already passed this milestone for EF1 and EF3. It means the front and the back end of the aircraft. And now we are finishing with the center of fuselage the same journey, and in the coming weeks we will have achieved enough evidence to start operations. Nevertheless, this testing will continue in 2015 and perhaps even at the beginning of 2016. So it is a long journey where we will expose this structure to many cycles after several design service goals representation. So that's on the structure side, and so far so good, I would say. Now, flight test itself, 5 aircraft will be flying soon, and certainly MSN5 will be the most visible one in the last phase of the test campaign. I said 1900 hours projection that what we need for certification is around 2,500, 2,600. We'll see precisely the numbers, but for sure with the fleet of 5 aircraft, we will have no real difficulty to accumulate the number of flight hours that we need and the number of tests that we need for the certifications. And actually, certification is not just aircraft flying; it's also the results of tests and a lot of certification documents that we need to deliver to our authorities. And need their blessing before we can get to the type certificate. So this is going quite well until we have a clear path to a certified aircraft, and certainly we expect that we will have deliver our share of the work before the end of the summer, and then it will be the final discussions with the IATA and FAA following closely what the IATA are doing and are requesting and are approving. So that's a plan. Route to certification I need to cross fingers because every day aircraft flying, so there is always a little uncertainty, but we have a lot of confidence to be able to achieve what is needed for the type certificate of the 350-900 before the end of the Q3 and end of the summer. So that's first important end of development, which will materialize with the type certificate and later on with the delivery of the first aircraft to the customer. And then we will enter another journey which will be even more industrial for the Dash 900. So that's one of the prerequisites to deliver have a certified safe aircraft. And now, of course, the other two important streams are first, we need to be happy that we have reached the level of maturity that will enable our customer to operate this aircraft, and second, we'll have to convince the customer that we've done so. So that's why we thought, knowing the time scale, if we succeed what we are doing, and when we succeed, I should say, what we are doing, we will have a certified first flight to type cert, kind of 15 months, which is something that I think, if you compare to previous experience, is significantly shorter, and therefore, of course, in the same time, we fly, so we find a lot of small things that could affect operation, and that we need to fix very quickly. And this is why, since the beginning of the flight test program, we have put in place this concept of Airline 1, which I touched upon last year. And this concept is nothing else than a means to accelerate the maturity at the end of the development. This is just an additional tool. We want to operate during the flight test campaign this aircraft like as much as possible like an airline would do, which means that we have put around the flight test team a small team and dedicated facilities that enable us to, with modesty I would say, but to operate like an airline would do. This means that we need to be, this team needs to be very close to the flight ops and have all the findings immediately grasped from the real life. And then in terms of maintenance and in terms of troubleshooting, we need to also have this team operating with the means that our customers will have. And of course, to do that and to find sometimes quick fixes to small issues that need to have a very high level of proximity with engineering and with our suppliers. So this is about the concept, the dedicated facilities. We have them. We have built a special hangar for us, which enables the daily maintenance and perhaps later on working parties if we have to. We have a maintenance control center and maintenance control echelon operating with our flight test team. So this is the setup. The concept is simple: operate and test the aircraft like if we were, as much as possible, doing still flight tests, but as much as possible in an operational environment. Use the maintenance systems and the support system that our customers would have. Capture the findings as soon as possible and fix the issues as quickly as possible, and trying to reduce as much as we can the time to get the fixes. So that's two aspects actually. It's aircraft maturity, how to accelerate it, and how do we feel about operability when time comes. What is our view? What do we need to anticipate with the customer? How do we need to prepare him for this journey? So that's in a bit more details for aircraft maturity. Since the beginning of the program, we were chasing all the findings from the other program, from our environment, particularly for Airbus aircraft, trying to find what was relevant to us, what did we need to do with the design or with the testing to demonstrate that the issues that other programs had would not be likely to happen in the A350. So that has been in place from the beginning, but now, of course, it's about the product maturity items that come directly from the flight test. Most of them we will have time to fix them before delivery, and perhaps some of them we won't have time to fix them, so it might turn into small limitation in some areas. So we need to prepare ourselves and to prepare our support to the first customer to be successfully operating this aircraft. And this is based on the product, but it's also touching the support system, the technical documentation, the ground support equipment, and the way the aircraft will be tested with those means, either built in the aircraft or external means. And this is why we have these operational test campaigns, which really train ourselves to testing the aircraft like operational airlines would do, using the tools and improving those tools as we use them. And then, of course, come the problem of operability of this aircraft. Our customers are rightly demanding. They want to be able to operate this aircraft like if it was an aircraft with 10 years experience. Of course, it's a challenge. It's a challenge for every new aircraft, and you have witnessed this in the last programs, not just with Airbus. So how are we going to prepare ourselves? One of the issues that we usually have at the beginning of flight test or at the beginning of operations with airlines with a new aircraft is number of spurious messages or built-in tests which give too much information. So we've been working these issues with, of course, a goal which would be to reduce as much as possible those spurious messages that could happen with a new system, any new system in the world, and how can we, of course, fix most of them. Ideally, we would like to have a page of dispatch messages with no dispatch message at the start of operations, and if we are not there, how can we anticipate and mitigate the risk with our customers? So that's all about this Airline 1, and this is really for us a very interesting experience that we are having for the first time on this program. I think whatever will happen in the future, I think this experience will have brought a lot in terms of confidence that we have, that we will know exactly what we deliver, and that we will have done the best possible compromise between delivering to the customer a perfect aircraft and recognizing that at some point there is a need for this compromise to be done. So one important test that was done in the last weeks was about LSM-2, our cabin-equipped aircraft flying passengers, Airbus passengers. And we had two early long flights, one by day, one by night, and these. I think this is always a very successful and very rewarding exercise for our workforce, and people all want to be part of it. Fortunately, we had only 500 seats overall, so we had to make selections of people. But we had very good feedbacks from generally from either the passengers or the crews that operated the aircraft, and we had the first aircraft in first flight operated by Evrard, the second one by Lufthansa. So generally we had very good feedback about spaciousness, about it's easy to serve for the crew. It's wonderful lighting. You can see here that atmosphere, the mood that we can create through the lighting, the aircraft. Air conditioning was also recognized very good quality. The flights were very smooth, and comfort is high. And the IFE, you can see all people fascinated by the IFE and the real-time connectivity. So that was really for a very good impression. Of course, a lot of details as well that we will improve over time. And this was also very precious exercise for us to accelerate the findings of those details. When you have 500 passengers and 20 crew members, and you have a lot of feedbacks, and we will analyze all this and of course take a great account of this feedback. This follows the previous exercise that we had a year ago, which was a virtual first flight in Hamburg, using our cabin test bench in Hamburg. So this is just the second step, is real life. So that's about what I wanted to say on development. Now, of course, our next journey is about maturity of demonstrating that we have a mature product that we can ramp up in production. And actually, before going into details, I just wanted to show you a video, which is a tour of all our plants, almost all our plants. And you will see that maturity and production ramp up is now and is already happening. I'm not sure if I have to press the button or I We can see that in our plants they are working on the aircraft depending on the level of completion and the level of the component that the plants are making. We are between around 38, around in the pre-final assembly line, around 18, and in the final assembly line we have around 10, which is already. And actually we are going slowly but surely up to this curve here, which is going to take us to rate 10 4 years after now, actually. So the next, well, today we are at around rate 2 in the start of final assembly line. Means every 2 weeks we have a new set of major components entering the final assembly line, and we are heading towards the beginning of next year, a rate which is close to rate 3 in the fall. So that's our journey. This journey is followed with regular reviews that controls the maturity of the product and the risk of accelerating the pace, because you can imagine that behind this industrial achievement there is also a very more and more significant investment and inventories building up. So we have to be able to deliver and to continue accelerating. So the key success factors we discussed this several times already. Are the same. The stability of the design, of course, certification on time, because the later we have the certification, the more work in progress we would have in the fall and beyond. But it's certainly the second driver, which is our industrial supply chain readiness, is one of the most important factors, and then of course our ability to define the head-up version that our customers will request, and finally to insert the Dash 1000 into this production flow. And when we have the Dash 1000 entering the final assembly line at the end of next year, this is of course using in most of the plants the same factories, sometimes dedicated tools, sometimes the same tools. So it's an additional problematic that is ahead of us and that we are taking seriously. In terms of design, I think the flight test program has demonstrated that in terms of, particularly on the new technologies that we had embarked in the SU-50 design, they are all there with a sufficient level of maturity. We had no issue with the electrical distribution system. The CFRP skin of the aircraft is performing well, including during a lot of icing and lighting strike tests that we had. Our new load alleviation function makes our design quite stable. We didn't have major new loop of loads and stress activity during the flight test program, which is quite new and quite unusual. And then finally, this lithium-ion battery, which will equip the 350 after EIS. Today we are qualifying actually two solutions. One is the NiCad battery using the 380 battery at the start of operation at EIS, and then later on we will move on to a lithium-ion battery, which is already used in the development and test aircraft. So this is, from a technology point of view, I must say that we have mastered it in a satisfactory way, and we have no high risk coming out of the flight test or the other test program. From a supply chain point of view, still a very hot topic for me, and at the end of the program I need to make sure that everybody is working at the same pace. So over 200 suppliers in the program is a significant number, not all tier ones, but we have a long chain, and Tier 2 needs to be visible from us as well. So if we look at in terms of number of more critical ones, we have still resident teams and very rigorous process to develop them further and to help them transforming themselves and get up to the challenge that the S350 poses to them. I think we have around 2% to 3% of the supply of the overall amount. So it means that in terms of maturity of our supply chain, it's getting there, not yet there fully, and this year, 2014, and probably next year will still be for us an opportunity to develop their capability further, and for the last ones to put in place their final industrial system, their final ERP system, their final engineering support. This is the kind of topic that we are helping them to put in place. From a customization point of view, this program was a breakthrough. We changed the way of working. We have developed from the beginning a very much more robust customization solution for our customers based on a more friendly aircraft, green aircraft, able to take a large variety of cabin configurations, and also developing the catalog of cabin and equipment solutions. So this was all in place. There was a brick still to be put in place to phase the ramp-up. That was the Customer Definition Center that was inaugurated officially on the 7th of April in Hamburg. And this tool is very useful to welcome our customer teams and define with them the cabin that they want. And you can see here on this curve that going forward, we will have more and more cabin definition per year. We are currently addressing 10 CDFs this year, and then we will go even further in the following year. So this ramp-up is equally important, because even if the aircraft is more friendly than before, and if the customization does not affect the lower end of our supply chain, where people are working on standard aircraft, then at the upper end, which is the final assembly line, and also our pre-final assembly line, we have, of course, an interaction between this cabin definition, the engineering of it, and its industrial implementation. So that's about this curve. I think we feel good to be able to face this 10 configuration this year. And then we will need to continue to accelerate and to reduce the lead times between the time when we freeze the cabin with our customers and the time we deliver the aircraft to him. So that's about the maturity for the industrial side. So it's maturity of the design, stability of the design, stability of our supply chain, and ability to address the head-up version simultaneously. Now, for the Dash 1000 is for sure taking full benefit of all the 900 journey development and also industrial. The same industrial system will take over the Dash 1000 progressively, and actually it is starting now. At the end of last year, we had our normal process to review the maturity of the design and to give us a blessing for launching the industrial tooling, the big tooling that are required to make the big specific parts of the Dash 1000, because even when parts are almost common, they have to be resized. If I take the wing, for instance, we have to resize the wing covers to the loads of the Dash 1000. So this is not revolution, that's evolution, but requiring, in the world of composite, requiring, again, big tools with long lead items, with long cycles, that needed to be launched on time to be able to produce on time. And actually, this is what is going to happen during the summer. the longest lead item will start producing during the summer. We start cutting metal and laying up carbon fiber in Nantes, for instance. And on the engine side, the Rolls-Royce is following a similar roadmap, and they are now preparing the first engine to test. And we will start the testing of it during the summer normally. So that's all taking shape, and at the end of this year we will already be in the assembly of the major component item in our CA component assembly plants, and then moving forward at the middle of next year. We will be in Saint-Nazaire and Hamburg preparing for the file delivery at the end of next year. So that's the plan, that's the roadmap. Still, of course, a lot to do. Nothing's granted, nothing's given, but we have all the lessons and all the experience. And actually, just mentioning a couple of experience where, of course, the Dash 900 helps a lot, making the Dash 1000 a much lower risk aircraft compared to what 900 was at the time. If I take the flight test data, we have the flight test data, so we can have a smaller flight test instrumentation in the Dash 1000, and this will enable to gain time in the file process. We have all the results of the structure, so we are able to size the Dash 1000 with not just prediction but also results of testing, and some incorporation of new technology have been made to gain efficiency again for the Dash 1000. And just these two examples, but there would be more to say, but these two are significant. 4 of the 8 passenger doors will have door surrounds, which is the frames around the door, made of carbon fiber instead of titanium for the 900, and also the pylon will receive for the first time a composite spar. So this is experience and also new technology applications, taking the composite technology one little step beyond the 900. These are just examples of tooling that are already there and that will make these big parts. To prepare for the testing phase, we also need to shorten the testing phase compared to the 900. This will be achieved by using much more simulation. The 900 was a breakthrough in terms of testing strategy, going to much more functional testing and much earlier testing shared differently with our systems suppliers. For the 900, after the 900 experience, then we have the Dash 1000, and here the next step is going to replace some of the testing by simulation. We are not going to rebuild a completely new Iron Bird. We will proceed by simulation and by delta. Compared to the 900, we will not replicate the 1G wing bending test, where you need to bend the test on the 1G load to demonstrate that all the systems and all the movables work without interaction. We are confident that we can do that by simulation, because we will have a perfect calibration of our deflection tools that are able to work out the deflection of the wings and the movables under certain conditions. We have, of course, other gains in terms of efficiency in the system installation world. And for instance, again, the way we install the systems is very similar to the 900. So we go much faster than it was the case on the 900, replacing interface point one by one creation by porting of packages of interface points on a given zone from the 900 to the Dash 1000. That just give you an example, and there would be even more to say on this topic. And Rolls-Royce is also using a lot of new technology in the 97K engine that is required for the Dash 1000. And for instance, they are using 3D printing with titanium parts to accelerate the manufacturing of some of the parts. So all this is all new with reasonable step forward that will just give us another level of the next level of efficiency, and also will enable us to reduce lead time. The engine itself, the lead time for development is this one. It's similar to the 900 but shorter. And for instance, between the first engine to test and the flight test under an S380 flying test bed that we will replicate because it was very successful on the 900, and it gave us at the start of the flight test program of the S350 900 a very mature engine that we will replicate the same process and have in middle of 2015 S380 carrying this 97K engine before we fly it on a real S350. So that's in a few words that about the Dash 1000 I can say, and this brings me to just a wrap up. So the certification need to cross my fingers, but we feel confident. Every year, of course, every day is important, and every day brings its contribution. But we have no showstopper today. We have, nevertheless, still a very busy flight test period during the summer. So I can tell you that the flight test team, who already did a huge and great job since 1 year, has another summer, hot summer in front of them. Then, of course, this is for the final assembly line team, completing these two first customer and bringing them as much as close as possible to the delivery and to the customer, and this requires a very high quality standard. We have a customer who is very attached to quality, and we want to satisfy him. We have, of course, also this maturity topics, which is aiming at providing an aircraft that the customer can operate, but also an aircraft that our industrial system can safely produce and going up the ramp-up curve. So this is definitely another year of high pressure on the supply chain in front of us, and there is no reason to be 100% confident, but there is no reason to not be confident either, because we made a lot of progress with most of them. And then the customization, the last brick of the ramp-up, which is coming together. The Dash 1000 has its own path. There is a specific team working on it, and this team is now at a stable level of engineering effort. All the suppliers are mobilized, and I think it looks promising. So lessons learned, innovation, enabling to reduce our lead time and adhere as much as possible to the schedule. This is what is ahead of the Dash 1000 team. So as you can see, it's a lot going on in the program. Still in the final stage of development for the 900, but in the middle of the development for the Dash 1000, actually starting the industrial journey. And altogether, this gives a very efficient family to our customers, and with a lot of them just in the coming months and years. So thank you.
Thank you, Didier.